Hey everybody, it's Mr. Cassandra here. We're going to talk about chapter 9.1 today and an introduction to what's called a quadratic function, which is a nonlinear function that can be written in a form of f of x or y is equal to ax squared plus bx plus c. That should look familiar because we did some factoring with things in that form. We call them quadratic equations. You'll notice that it has a squared term and it has a linear term, which is just an x to the first power, and then it has a constant term, which is c. So anything that's in that form with an x squared is going to be considered a quadratic function, and it will have a u-shaped graph called a parabola. So in this lesson, we are going to learn how to graph quadratic functions, and we're going to be concerned with what's called the parent graph, and variations on the parent graph, as well as ones where the vertex is being translated up or down the y-axis. So you're going to want to put this in your notes, either pause the video or go to page 570 of your online textbook. And it says right here, the parent quadratic function is y equals x squared. So I graphed that for you right here in my notes. Okay, y equals x squared. So what I did was I made a little table of values and I found out, okay, so if x equals 0, what is y going to equal? And of course 0 squared is 0. And if x is 1, 1 squared is 1. And if x is 2, 2 squared is 4. Right? Then here's where people get themselves all caught up and they get into trouble. When they have a negative number squared, sometimes they put it in the calculator wrong. So I guess my question is to you, why are you doing negative 1 squared in a calculator anyway? Negative 1 squared is negative 1 times negative 1, which is positive 1. That's it. Same thing with negative 2 squared. That's negative 2 times negative 2, which is positive 4, because a negative times a negative is positive. In fact, whenever you square the x value in this table, it's always going to end up positive when you square the x. So that is the parent graph, getting back to here again. So the parent graph is y equals x squared. You'll notice that the vertex of the parent graph is 0, 0, which is the origin. The vertex is the highest or lowest point of a parabola or a U-shaped graph. And the axis of symmetry is the vertical line that goes right down the middle and splits the parabola into two curved pieces, so that when you fold the one piece over onto the other, it will fold evenly. So that is the axis of symmetry. So the axis of symmetry for every graph we're going to be doing in this lesson is the y-axis. So let's get back then to my examples here. What happens if I have y equals 2x squared? That kind of looks like the first example, y equals x squared. Only now there's a 2 in front of it. Well, what that does is that just adds a little extra step to our table of values. So instead of just squaring something and I'm done, the order of operations says I have to square the x first, and when I'm done, I'm going to multiply it by 2. So please follow the order of operations. Exponents comes before multiplication. 2 times x squared means you do the x squared first and then times 2. So I gave you a couple of examples of that down here. Once again, the vertex is still going to be the origin because 0 squared is 0 and 2 times 0 is 0. So that's that work right there. And that's why you get that. And now you have substitute 1 in for x. You have 2 times 1 squared, and 1 squared is 1. And 2 times 1 is 2. So this is all very basic computational stuff. What about if I do 2 times 2 squared? Well, 2 times 2 squared would be 2 times 4, and 2 times 4 is 8. Okay? If you do the negatives, you're going to get the same thing because this graph has symmetry. You'll notice how you have two different x values that have the same y value. That's going to happen in a quadratic function. If I do negative 1 squared, negative 1 times negative 1 is 1, and 2 times 1 is 2, and the same thing with negative 2. Negative 2 squared is negative 2 times negative 2, which is 4. 2 times 4 is 8, and that's your graph. Now, you'll notice the difference between these two graphs. This graph here does not go up quite as fast as this one here. This one goes up faster. Well, that makes sense because, of course, the y values are going to go up faster because there's a 2 in front of it. So it's going to go faster. Okay, so I did a couple more examples I want to show you, and then we're going to do an activity for homework. There's going to be an activity assigned to you, and you're going to be exploring this, but this gives you a little preview of some of the exploration. So what happens if I have y equals negative 1/2 x squared? Well, I'll let you see using the graph here. Obviously, that looks different from the previous graphs that we just did. And you can see as I put them side by side, this one opens up, this one opens down. So what's the difference? Well, I think it's pretty plain to see. This one has a negative sign in front of it, and this one had a positive in front of it. So if you fill out the table of values here, you still have 0, 0 for the vertex. Notice when you put an odd number in and square it, and then you do half, you're going to get a fraction. So for that reason, whenever you have a fraction, whatever the denominator is, you want to use multiples of that number. So this is 1/2, so you're going to do 2 and 4 in your table. Okay, we're not actually going to be filling out any tables for homework today, but on tomorrow's homework we will. So I'm going to go back over this again tomorrow. All right, so I filled out the table there, and you can pause the video and take a look at that if you like, or try that table yourself. And in the last two examples now, we have something that is being added or subtracted. So you'll notice what happened here is if you have y equals x squared minus 3, it's exactly the same as this graph, except the entire thing has been, let's see if I can do some magic here while I'm videotaping and doing this. So you'll notice the entire thing has been shifted down. So it was here, but now it's been shifted down 2 units. That's what the minus 3 does. It shifts all of those y values down 3 units. So you're going to see that in the activity that you're going to be doing. And last but not least, I kind of put a couple of things together here. I have my negative coefficient. I have a 3, which makes it more narrow. And I have a +7, which shifts the whole graph up. So, so that really kind of tied everything together. So we're going to be doing a little bit more of an exploration with this tomorrow as well. But this is just an intro, so I wanted to show you all the graphs. You're going to do the Desmos activity for homework. Please make sure you try to get the correct answers. If you have all wrong answers, I'm going to just ask you to do the Desmos activity again. So please make sure that you're not just writing anything in the text boxes. Read the slides, try your best, because I do not want to have to return it to you as unacceptable, and I want you to get credit. So do your best. If you have any questions, shoot me a private message or an email, and I'll be happy to set up a meeting as usual. Have a good day.